everybody. I think we'll start with a quick review of your sketches. So let's just jump in and sketch y equals cotangent 1/2 x minus pi over 8. Now, I am not privy to exactly your conversation about this, but let's just recall that the standard cotangent has an asymptote at 0, an asymptote at pi, a 0 or an x-intercept at pi over 2, and it is a decreasing function. So this is a picture of the cotangent. Now, obviously, we've stuck some stuff in here that's going to change the way my cotangent looks. Everything in the picture has been shifted pi over 8 to the right. To the right. So that means that I'm going to have an asymptote over here at pi over 8. And I'm going to have another asymptote over here somewhere. Be careful, we've changed the period. So our starting point, whatever happened at the origin, is now happening at positive pi over 8. Shifted shifted pi over 8 units to the right. In between here, I have my 0 and I have my decreasing function. So the only thing left for me to do is figure out the labels on this asymptote and that 0, that intercept there. So I recall that for the normal cotangent, the period is pi, or 180. When you put a coefficient on x, it divides the period. That coefficient, just like you learned back in chapter 1, that coefficient divides the period, or the horizontal. So, if my period was supposed to be pi, it's now been divided by a half, which means it's now times 2 pi. So the distance from asymptote to asymptote, instead of being pi, is now 2 pi. So let's see, that's 1/8, and I have to add 2/8, or excuse me, I have to add 2 to that. So this is going to be 1/8 plus 16/8 if I get a common denominator. So this is 17 pi over 8. The distance from 1 to 17 is 16/8. That point is always right smack dab in the middle. So the average or the midpoint of 1 and 17 is 9. Remember, to find the midpoint, we average, add, and divide by 2. So 1 and 17 is 18, divided by 2 is 9. So there is a picture of that curve. Okay, now let's do one more review problem from your conversation yesterday. Let's do a cosecant. Now remember, the beauty of video is you can stop me, you can rewind me, you can watch me as many times as you want. So here we go, cosecant 2x plus pi over 5. Now from your conversation yesterday, you know that the cosecant is the reciprocal of the sine. So there is my sine curve. Every time I have a 0 or an x-intercept, I drop in an asymptote and I flip my curves. Now that is a picture of the regular cosecant. Like the regular sine, its period is 2 pi. In this picture, we've made some changes. I'm going to start with a regular sine curve again, just like I did here with my dashed line. I'm going to do a regular sine curve. So I see I've got a shift of negative pi over 8. So my sine curve is going to look like this. Okay? Now, every time I cross the axis, I'm going to have an asymptote. Every time I have a 0, because 1 over 0 is undefined. So if you have a 0, when you flip it over, it's going to be undefined. And then I'm going to flip my hill up and my valley down. And there you go. So I'll take this out so it doesn't confuse you. But I am ancient, and I always start with the sine. If I'm graphing a cosecant, I just think it's easier to start with the sine. But this is the actual graph. Now, I know that my beginning asymptote, I'm not sure why I said 8, that should be 5. I know that my beginning asymptote is at negative pi over 5. Now, I need to find the end. So I need to calculate the period of this picture. I know that a coefficient on x divides the period. So this is going to be 2 pi over 2. So the period of this function is pi. Okay? That means from here to here is pi. One cycle of the function. One hill, one valley. So if I start at negative 1/5 and add 1, so that's negative 1/5 pi, that's 1, this distance is 1 pi, then this label is going to be at 4/5 pi. Negative 1/5 plus 5/5. I'm starting at negative 1/5, traveling 1 whole, so I'm going to end up at 4/5. Now this asymptote is right in the middle of negative 1/5 and positive 4/5. That asymptote is right in the middle of that. So I need to find the average of these two numbers. So I'm going to add them. And this time, it's not quite as easy. In order to take half, I'm going to have to multiply by a half. Averaging is adding and dividing by 2, adding and multiplying by a half. So this is going to be 3 pi over 10. That is halfway between these two asymptotes. Now, right here, what was the top of the hill for the sine, but is now the bottom of that parabola, that has to be labeled. That's like the minimum on this part of the graph. So that is the midpoint of negative 1/5 and 3/10. So I have to add those. So that'll be negative 2/10 and 3/10. That gives me 1/10. But then I need to take half of it. So, oh my gosh, this is pi over 20. Don't you dare get bogged down in the arithmetic. Kids, you're finding the midpoint. And the midpoint is average. Add and divide by 2. So I added negative 2/10 and 3/10, got 1/10. Half of that is 1/20. Now I'm going to do the same thing here. So I have 3/10 and 4/5. Finding that point right there, the top of that parabola. So that's 3/10 and 8/10. So that gives me 11/10, and half of that is 11/20. Now I want to show you something that sometimes you might want to think about. If we just get a common denominator all the way across, this would be negative 4/20. So we're going from negative 4/20 to 1/20. And then we're going to 6/20, and then 11/20, and then 16/20. Now, what do you notice? If I get a common denominator with all those labels, what do you notice? They're 5/20 apart. These should always be equally spaced. they should always be a fourth of the period. So this is pi over 4, 5/20. This is pi over 4, and so on. All right, so that's review. That's stuff that you've already kind of spent some time in class on. What we want to do now is solve some equations using these reciprocal functions. All right, here's what I mean by that. Let's solve this equation, and let's solve it between 0 and 2 pi. So what this means is, don't let it wig you out. You're trying to find all the values of x so that the secant is 2 over root 3. Now again, I am not exactly sure how you've approached this, so here's how I approach it. I'm going to draw myself a triangle in quadrant 1. This is a positive number, so I'm just trying to figure out what angle I've got, so I'm just drawing it in quadrant 1. The hypotenuse is 2, and the adjacent side is root 3. Because by definition, secant is either hypotenuse over adjacent, or if you prefer, r over x. R over x, if you think of this as a big circle. That's a special right triangle. If we're doing it without a calculator, which I can't remember if I told you or not, we're doing this without a calculator. If we're doing it without a calculator, it has to be one of our special angles. So here's our 30, 60, 90 triangle. And across from the 1 is 30, or pi over 6. So the angle that has a secant of 2 over root 3 is pi over 6. Now the question becomes, are there other angles that have the same secant? Well, be careful. R over x, R is always positive. R is positive, 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 always, always, always. If this is going to be a positive fraction, then x has to be positive. So it's not going to happen. You're not going to have a solution in quadrant 2, and you're not going to have a solution in quadrant 3. But you could have another solution in quadrant 4, because in quadrant 4, the x will still be positive. This is always positive. R, hypotenuse, always positive. So this is a pi over 6 angle. When you have these multiple answers, the reference triangles are always exactly the same. They're congruent. So once I figured out that was pi over 6, I knew any other reference angle was going to be pi over 6. So then my other answer to the problem in standard position starts here, goes all the way around to my angle. So how big would that angle be? Keep in mind, a full revolution is 2 pi. You didn't quite make it all the way around. You didn't go this last little part. So won't this big blue angle be 2 pi minus pi over 6? It's the whole 2 pi except for pi over 6. So that would be what? 11 pi over 6. 12/6 minus 1/6. And there's the answer to the question. Now, somebody's going to say, well, Ms. Ford, why don't we say, wouldn't it be easier just to say negative pi over 6? That angle is negative pi over 6, but pay attention to your directions. Are you allowed to have a negative angle in this particular problem? No, you're not. So the answers are right here, pi over 6 and 11 pi over 6. All right, let's try another one. No calculator. Let's try tan x equals -1. And this time, we're here. That's our domain. These are our x, our possible x values. That's our domain. Let's not worry about that. Let's figure out the angle first. To take care of this, we just have to figure out where to put the angle, which quadrant. But right now, what is the angle? So I'm going to go ahead and draw it in quadrant 1. Oh, that won't work. That's negative. That can't be in quadrant 1. But let's draw it anyhow, just to figure out the angle. So the tangent is 1. I know it's negative. That means I'm going to have to move it. But let's just figure out the angle. Maybe you already know it. If these are 1s, this is 1/1. If these are 1s, then the reference angle is going to be 45 or pi/4. Now, that tells me how big my reference angle is. So somewhere, I'm going to have angles, reference angles that are pi/4, and it is not going to be quadrant 1 because it has to be negative. So where would the tangent be negative? Wouldn't it be negative over here? Now this is still pi/4, but now I have a negative. Where else is it negative? In quadrant 4. The tangent will be negative in those two quadrants. So to solve this equation, you need to figure out your reference angle. I did that, pi/4. And then I have to figure out where it's at. It's either in quadrant 2 or quadrant 4. Now, gang, that means that my answers are this angle or this angle. Now let's figure those out and then we'll talk about what might be wrong with those answers. What would this one be? The big blue one here. What would the blue one be? Well, remember, this is pi, halfway around. So that would be 3 pi/4. This is a fourth, so this has to be 3/4 because that's a whole. And then the red one, all the way around, would be 7/4. Because all the way around is 2 pi, but you're going minus a fourth. So 8 minus 1, 8/4 minus 1/4, 7/4. Now, those are absolutely correct answers, but we have a bit of a problem. This one is fine, because that one's in this interval right here. That's fine. But this one is bigger than pi. Would you agree with me? So instead of saying, because this time I'm allowed to go negative, instead of saying 7 pi/4, this time I'm going to say negative pi/4. Now, are they in the same place? Yes, they are coterminal angles. They are in the same place. Why am I choosing to say negative? Because that's my domain. My domain says I have to go from negative pi to positive pi. And I can't have a number outside of that domain. So I had to rename 7 pi/4 as its negative coterminal. The answers are still in quadrant 2 and quadrant 4. This is just a matter of how you name the angle. Personally, I like positive angles better, but don't have a choice this time. All right, let's try one more without the calculator, and then we'll do a couple with the calculator. All right, so here we go. Cotangent 1/-√3. And this time my domain is pi to 2 pi. All right. So here we go. I need an angle, and I'm just randomly going to draw an angle, try to figure out how big my angle is. I need adjacent to be 1 and opposite to be √3. Cotangent is adjacent over opposite, x over y. So I know that special triangle, I know that's a 60. This is a 30, 60, 90 triangle. That's a 60. It's pi over 3. Now, you may have all that stuff memorized. I really don't know. I don't. I figure it out each time. But we need to get a pi over 3 angle. So our angle this time is pi over 3. Okay? Now, let's start with our domain. This time, our domain is pi to 2 pi. So this is pi, this is 2 pi, this is my domain. So whatever triangles I draw have to be down here. No other place in this problem. I need the cotangent to be negative. Now, I want you to look what happens over here. This is adjacent over opposite. So this would look like this. Is the cotangent going to be negative in this quadrant? Absolutely not. So I cannot be in that quadrant because cotangent will be positive. Will cotangent be negative in this quadrant? Yes. Yes. And I know this is a pi over 3 angle. Once I figure out my reference angle, that will never change. Every triangle I draw for this problem is going to have a reference angle of pi over 3. That means the angle at the origin is going to be pi over 3. This one would be pi over 3, but it doesn't count because it doesn't give me a negative cotangent. And I'm only considering these two because that's what this says. If it said 0 to 2 pi, I'd be looking here and here also, like I did in my earlier problem. But not now, only down here. Now, again, some of you might say, well, let's just say negative pi over 3. That would be a great answer, but it doesn't fit the domain. So in this problem, we have no choice but to go all the way around because we have to have a big angle between 180 and 360. Negative 60 doesn't qualify. So what would that answer be then? Ultimately, we're only going to get one answer. What would it be? Well, all the way around, except 1/3 pi, would be 5 pi over 3. Remember, all the way around is 2 pi. So I am going all the way around except for pi over 3. Okay, now we got to do a couple on our calculator, so get your calculator out. We're going to do exactly the same thing. The only difference is, kids, we're not going to have to figure out the angle. We're going to allow our calculator to do that. So here we go. The board a little cleaned off here. All right, let's try 10x equals 1.9. Notice it's not a √3 or a 1/2 or, something, it's a random number. And we're between 0 and 2 pi. So we're going to go all the way around. We're going to look everywhere. Now, I'm not saying that these are all going to be answers, but we're going to consider the possibility of all those being answers. Okay? So, I'm going to go to my calculator. Now, this is a radian problem. So I'm going to make sure my calculator is set in radian mode, so everybody knows how to do that. Press mode, highlight radians, press enter. Now, what I'm going to type in my calculator is second tangent 1.9. So second tangent 1.9, because that's how I find an angle on my calculator. If I am searching for an angle, I must use my second options. Okay, so that's 1.09. I'll just round it off to the nearest hundred. So my reference angle is 1.09. Okay, so now I got to decide. I got these 1.09s all over the place. I got to decide which ones am I going to actually consider for this problem. Keep in mind, this is a positive number. Where is the tangent positive? Well, it's certainly positive right here, quadrant 1. So one of my answers is 1.09. Where else is the tangent positive? Not in quadrant 2, but it is in quadrant 3. How do I know the tangent is positive in quadrant 3? Because tangent is y over x. And in quadrant 3, they're both negative. Y and x are both negative. So the tangent is positive. Remember that the sine, S-I-G-N, of your functions depends on whether x and y are positive and negative, and that depends on the quadrant you're in. So I need this red angle. Well, I'm going to use my calculator. That red angle is simply going to be pi plus 1.09. So pi plus 1.09, 4.23. So the other answer to the problem is 4.23. Okay? All right, let's try another one. Oh, by the way, we couldn't be in quadrant 4 either. Tangent is not positive in quadrant 4. Because y is negative down there. All right, let's see. Secant equals negative 2.75, and we're from negative pi to pi again. Now, what this says to me is very clearly, I have to be here or here. That's it. Oh, no, that's not right. Never mind. Forget that. Forget that. That's not right at all. I can be everywhere. I can be everywhere. Let's go ahead and find our angle. Forget that. Rewind. Let's find the angle whose secant is 2.75. Now, I'm not going to worry about the negative right now. That might actually mess me up. So I'm going to think about this. If this, I'm going to drop the negative for a minute. That's going to be a quadrant thing. I'll figure that out. I need to know my reference angle, okay? I need to know my reference angle. So to find my reference angle, I'm going to think about the cosine being 1 over 2.75. Now again, I'm dropping the negative because all that's going to do is tell me which quadrant. I'm going to figure that out on my own. I need to know how big that angle is, depending on whatever quadrant I put it in. How big is that angle? So if the secant is 2.75, then the cosine will be 1 over that. So I will type in my calculator, secant cosine 1 over 2.75. So second cosine 1 divided by 2.75. And I got basically 1.2. It's 1.1986. So I'm just going to say 1.2. All right. Now, I have to decide which angles I'm talking about. And the first thing I have to pay attention to is that's negative. So where of these options, these are my options, the butterfly bow tie, of those options, which ones will have a negative cosine, a negative secant, a negative cosine? The cosine is negative here and here. How do I know that? How do I know the cosine is negative in quadrant 2 and quadrant 3 because cosine is x. Remember, secant is r over x. And if you want that to be negative, then x has to be negative. So we're over here. We have a 1.2 here and a 1.2 here. So I need to know the measure of this blue angle. The blue angle. Remember, this is pi. So won't the measure of the blue angle be pi minus 1.2? Pi minus 1.2. So that's 1.94. So one of my answers is 1.94. That's the blue one. Pi minus 1.2. Now, what's the measure of the red one? Well, the red one would be pi plus 1.2? Wait a minute. Yes, it would be. But won't that be outside of my domain? If I did pi plus 1.2, wouldn't that put me outside my area? So instead of going this way with the red angle, I'm going to have to go this way. What would that measure be? Well, it's still going to be pi minus 1.2, but now it's going to be negative. So that is negative 1.94. Because if I went all the way to here, it would be pi, but I'm stopping 1.2 short. So it's pi minus 1.2. So this time, my answers are positive 1.94 and negative 1.94. Kids, there's a lot to keep track of. It is easy stuff, but I understand if you have any confusion because it is hard to keep track of all this stuff. Let's do one more example. One more example. Here we go. All right, so we've got cosecant equals 1.79, and this time, this is our domain. And these are just random domains I'm making up, because that's what they do in your book. So the first thing I need to do is figure out my reference angle. And then I'm going to figure out which of these triangles it applies to. I'll narrow it down. But first, I need my angle. So if the cosecant is 1.79, then the sine is 1 over 1.79. Would you agree with that? I hope. So the angle I'm looking for is second sine 1 over 1.79. So second sine 1 divided by 1.79, that's 0.59. So the angle is 0.59. Now, all of these are 0.59s, okay? Now, I need to consider only triangles that have a positive sign. So keeping in mind that sine is y over r, cosecant, this is sine, then cosecant is r over y, but either way, I'm looking at y. And I need y to be positive. So the only places that y is positive are the ones on the top. Those are the only places that y is positive. So my answer would be 0.59 or the blue one, which is pi minus 0.59. Oops, I just made a mistake there. Pi minus 0.59. Which is 2.55. And that's pi minus That's pi minus because all the way to here is pi, and I'm not doing the last 0.59. Now, I want you to look at your domain. That's the last thing we check, or it could be the first thing, doesn't matter, you got to check all this stuff. So the domain says that I have to be between pi over 2 and 3 pi over 2. So in other words, I have to be over here. That's what my domain says. You got to be over here. Well, if I have to be over here, then the only answer that's going to work is this one right here. 0.59 is an answer, but not in that domain because it's less than pi over 2. So the answer to that problem is only 2.55. So, moral of the story, find your reference angle. Make sure you put it in the right quadrants depending on the SIGN of the number you've been given. And then match up your answers to fit the requirements of your domain. Good job. Have a great day.